In this video, we're going to look at another U-substitution problem, but let's look at a little bit more difficult problem. Not too difficult, but it's difficult enough. Let's say, okay, let's say if we had the indefinite integral of 4x to the third power over x to the fourth plus 7 dx. Now this problem looks difficult, but really it's not, because we're just going to use U-substitution. And the reason why I say we use U-substitution, look at your values. You have x to the fourth plus 7, and if you took the derivative of that, if you took the derivative of this, you actually get 4x to the third power. So we can actually use U-substitution knowing that we have both a if we have a value then its derivative. So let's just put u equal to x to the fourth plus 7. Now what about in terms of du? Well, we know that du is just taking the derivative of u, so it'll be 4x to the third. Now this is actually the same thing as saying du over dx equaling, well, I take that back. Don't forget the dx here. We need the dx. But this is basically saying the same thing as du over dx equaling 4x to the third. Now this is not actually a fraction. It's just so we know that we're taking the derivative or the antiderivative, the definite integral, in terms of x. But you can for this, in this purpose, think of it as a fraction. If you want to get du by itself, all you do is multiply dx on both sides, so you can move the dx over. But these two are basically the same thing. It's just that we're writing it in a differential form so we can use U-substitution properly. So let's go ahead and look at the problem that we began with. Now we have the antiderivative or indefinite integral of 4x to the third over x to the fourth plus 7. Well, we can go ahead and substitute these values in, because we have this and this, both of these functions down here. So if we rewrite it, we have the antiderivative or indefinite integral of du over u, because du equaled 4x, and we can't forget dx, 4x to the third dx, that's what the top value is, and the bottom x to the fourth plus 7 is what we set u equal to. But we can also rewrite this if we wanted to. Actually, I take that back. If I can, we don't need the dx, because remember we got dx here. Here we go. 4x to the third. If I can write third. There we go. Dx here. That's why we substituted du there. I apologize. So we have du over u. So if we rewrite this again, we have the antiderivative of 1 over u du. This is basically essentially the same thing. I'm just writing it so we can have a better idea of what it looks like. So if we took the indefinite integral of this of 1 over u du, we basically have the natural law of absolute u. Remember, we're making sure that we can, if we have a u, it can be both negative and positive, as long as it's not 0, but it can have a negative or a positive value here, plus a constant. Now, this is the correct way of writing it, but we want to go ahead and resubstitute back in for any values that are left, such as u. So we have ln of absolute value of x to the 4th plus 7, that's what u equals, plus c. And this is our correct answer.